Basic math with Bunnywiggles and me. Hi guys, and welcome back to my YouTube channel, Amazing Maths with Chelsea, along with Miss Bunnywiggles. Before we start, please remember to like and subscribe below. Today, I'm going to talk about the importance of the Pythagorean theorem and the Cartesian plane, and how those two relate to each other. Even though Pythagoras and Descartes were centuries apart from each other, their ideas are still related to each other in some ways. First of all, let's go over the Pythagorean theorem, also known as Pythagoras' theorem. Pythagoras was an ancient Greek philosopher, which also meant that he had no last name. He was born on the island of Samos and traveled through Egypt and Babylon until he finally settled in Croton, Italy, which is modern-day Crotone. He founded a secretive cult-like school that required all followers to study mathematics, philosophy, and music, follow rules, and be vegetarian. The Pythagorean theorem was proven to have been attempted to be solved by both Babylonians and Egyptians, but only Pythagoras was able to successfully write the formula in its final form. His ideas heavily influenced Plato and helped to shape Western philosophy. As I mentioned before through text, the Pythagorean theorem is a squared plus b squared equals c squared, though you're probably wondering right now, what do all the letters mean? Here's a diagram of the formula. As you can probably tell, a squared is side a squared, and then b squared is side b squared, and c squared is side c squared, where c is the hypotenuse of the right triangle, where I should also note that the Pythagorean theorem only works for right triangles. And that's basically it for the Pythagorean theorem, though I should probably note that there are two special cases in the Pythagorean theorem where the three sides of this triangle form a ratio because the three angles of the right triangle form a unique set of numbers, such as the 45, 45, and 90 triangle and the 30, 60, and 90 triangle. The 45, 45, 90 triangle forms a side ratio of 1 to 1 to square root of 2. And then the 30, 60, and 90 triangle forms a side ratio of 1 to square root of 3 to 2. Those two special cases are quite useful when it comes to competition math. And the last important thing that I should note is that there's a list of basic Pythagorean triples listed right over here. That gives you leverage when memorized while solving difficult problems because it prevents you from actually having to solve the missing side length of the right triangle. The second person I'll talk about today is René Descartes, whose Latin name is Renatus Cartesius. As you can probably tell, his Latin last name is what led people to name what we sometimes refer to as the graph, the Cartesian plane. He is a French mathematician, philosopher, and scientist who is often referred to as the father of modern philosophy. His most famous quote is, "I think, therefore I am." He is also known for bridging algebra with geometry, which motivated him and inspired him to create the Cartesian coordinate plane, a way to connect shapes along with algebraic expressions. The Cartesian plane looks something like this. Here are three important formulas that you need to know in order to help you navigate through the world of graphs. Number 1, the slope formula. Number 2, the midpoint formula. And number 3, the distance formula, where Pythagoras comes again. Let's start with number 1, the slope formula. But first, what is the measure of a slope? The measure of a slope is how steep something is. And number 2, why does this matter? Let's say you're in a ski resort and someone didn't know their slopes. And if that person decided to measure the black diamond as a bunny hill or the bunny hill as a black diamond, that would be disastrous. Slopes also dictate water drainage, structural stability, energy, and material requirements in construction, geography, and mathematics. They determine how fast rain runs off of roofs, the risk of landslides in a terrain, and in math represent the change in linear equations in calculus. The slope formula is simply rise over run, as shown right over here. It can also be written as y1 minus y2 over x1 minus x2, where there are 2 points, the first one being x1, comma y1, and the second point being x2, comma y2. Number 2, the midpoint formula. This formula is exactly what it says in its name. It is used to find the midpoint of a line segment inside the Cartesian plane. Midpoints divide segments into equal halves, assisting in solving algebraic equations regarding lengths, and are also crucial for establishing symmetry. This is the midpoint formula. It is based off of the fact that any point in the Cartesian plane can be written as x, y. This means that the midpoint, which is, I have said, the center of a line segment, can also be written as x, y, where x is x1 plus x2 over 2, and y is y1 plus y2 over 2, where x1, y1 is the first point, and x2, y2 is the second point. Our last formula for the Cartesian plane is the distance formula, where Pythagoras comes to play again. The distance formula is based off of the Pythagorean theorem, because every little box and square inside of the Cartesian plane can also be written as a substitute for the 90-degree angle inside of a right triangle. The distance formula is very useful because it calculates the straight line distance between 2 points, which also allows us to find the relationship between geometric shapes on the coordinate plane. This is what it looks like. You can probably tell what it's asking you to do using the knowledge that you have right now that there are 2 points, x1, y1, and x2, y2. And also you can probably tell how it relates to the Pythagorean theorem because there are 2 expressions that are both squared and added up together and under a big square root. Now you can also probably tell why previously I said that the Cartesian plane connects both geometry and algebra together. Using your knowledge of the distance formula, you can do almost everything or anything you want regarding geometry because now you have the side lengths of the given figure. Here are your fun facts. I have 2 this time since I introduced 2 new people to you. The first one is about Pythagoras. He had a fear of fava beans, claimed to have a golden thigh, and believed that numbers were the essence of all things. He likely never ate beans, for he thought that it would trap souls. The second one was, guessed it, Descartes. He claimed to have invented the Cartesian coordinate system after watching a fly crawl over his ceiling. Now you know 4 more formulas that can help you guide you through your journey with math. I hope you found this video both fun and informative, so I hope to see you next time.